Use Pascal's triangle to expand 2k minus 3 to the power 5. So Pascal's triangle gives you the coefficient of each term. So we're expanding a plus b to the n, where the a is 2k, b is going to be minus 3, and n is the power you're raising it to, equals 5. So a bit later on, we're going to do this without using Pascal's triangle. We'll be using binomial coefficients. But right now, we're going to use the triangle to give you the coefficient of each term. So, what is Pascal's triangle? It starts kind of with a 1, and then you have a 1 and another 1. So you will see in the triangle, these are all 1s and 1s. Now, so the third row is going to have a 1 and a 1 on the outside, and then this number is made by adding this 1 and this 1. So from now on, each number, apart from the ones on the edge, are the sum of the 2 above it. So this is 2. So now I've got a 1, and I've now got 1 plus 2 is 3, 2 plus 1 is 3, and another 1, and so on. Keep going. So 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and then a 1. And then you've got a 1, 1 plus 4 is 5, 4 plus 6, 10, 6 plus 4, 10, 4 plus 1 is 5, and then you've got a 1 on the end. So things to note, it's completely symmetrical. So you have 1, 5, 1, 5, 10, 10, you've got 1, 4, 4, 1, 4, and a 6. Completely symmetrical every single row. I know which row I need, so every single coefficient, if you look at any given row, you have a 1 and an n, and from the other side a 1 and an n. So I know n needs to be 5, so I know I stop when the second number in is a 5. So this is the row that I want. Now, in this expansion, I know I'm going to have 6 terms, so you've always got one more term than n. Each term is made up of 3 things. It's a coefficient, which does actually tell you the number of combinations in the long expansion that would get that term. You don't really need to know that yet. So it's made up of a coefficient, a power of a, so a power of 2k, and a power of b, which is minus 3 in this case. So you're going to have 6 terms that are all 3 things being multiplied together. A coefficient, a power of one thing, and a power of another thing. So that means that 2k minus 3 to the power 5 equals, so the first one, coefficient is 1, equals 1, 2k to a power and minus 3 to a power. So general convention, you start with n for the first thing, for the a. So for the 2k I'm going to raise to the power 5, and you start from 0 with the minus 3. Another thing to notice, as we see the whole thing, these 2 powers always add up to n. So the second term, remember we need coefficient, power of the first thing, power of the second thing. Coefficient is 5. Power of the first thing, well, it's 2k, and we're going to drop that power by 1 to a 4, and then you've got minus 3, and we're going to raise this 0 by 1. Then we're on to this 10 plus 10, that's the coefficient, 2k, to drop the 4 to 3, and minus 3, you're going to raise the 1 to 2. Note, look, add up to 5, add up to 5. Then we've got another 10, so plus 10, 2k to a power, so 3 is going to go down to 2, and a minus 3, well, the minus 3 is going to go up to 3, still add up to 5, plus 2 more terms. 5 is the next coefficient, 2k to the power of 1, and minus 3 to the power of 4. And the final term, coefficient is 1, 2k to the power of 0, and minus 3 to the power of 5, which is going to be, just realise that's going to be quite a large number, isn't it? So we want to expand the whole thing as much as we can. So this first term, well, 1, and what this is 1, minus 3 to the power 0 is 1, so this is 2k to the power 5, so it's 2 to the 5 times k to the power 5. Well, 2 to the 5 is 2, 4, 8, 16, 32. So this is 32k to the power 5. Plus, well, I say plus, but if you look at this next term, you've got 5 times 2k to the power 4 times minus 3 to the power 1. So this minus 3 to the power 1 is going to make this thing negative. So you have, well, you've got 2 to the 4. You could do 2 to the 4 first, or you could do kind of 5 times minus 3, which is minus 15, and then times it by 2 4 times. I think I'm going to do that. So 5 times minus 3 is minus 15, so minus 30, minus 60, minus 120, minus 240, and then you've got k to the power 4 there. This one, is it going to be positive or negative? Well, that's positive, that's positive. Minus 3 squared will be positive, so this will be positive. And you have minus 3 squared is 9. 9 times 10 is 90, and then we've got to times that by 2 3 times, so 90, 180, 360, 720, so plus 720 is going to be k cubed. And then the next term, you've got minus 3 cubed is going to be negative again, so everything else is positive always, so minus, you have minus 3 cubed is minus 27, times the 10, minus 270, and you've got to times it by 2 twice, so minus 540, minus 1080, 1080 k squared. Next term, so we're done 1, 2, 3, 4, so we're on this term, so hopefully they're getting a bit smaller. You've got 5 times 2 times minus 3 to the power 4. So I think I'll do the minus 3 to the power 4 first. So minus 3 cubed is minus 27. If you times it by minus 3 again, well, 3 27s are 81. It's going to be positive. So then you've got that 81 times this, this 2, which would give you 162. If I then want to times it by 5, well, I could times it by 10, 1620, and divide it by 2. So 1620 divided by 2 is going to be 810. So 810, and it's just k. And then the final term, well, we've got, this is 1 times another 1, and then we've just got minus 3 to the power 5. So, well, we know it's going to be negative, and we just need to deal with 3 to the power 5. Well, 3 cubed is 27, so 27 times 3 is 81. 81 times 3, well, 80 times 3 is 240. 1 times 3 is 3, so it must be minus 243. So that is your final expansion. I wouldn't worry too much about these numeracy bits, so as in having to do big powers of numbers. It's a bit unfortunate if you get much of that. You might get it maybe for one term. I'm asking you to do the expansion. It doesn't really happen so much in exams, but just because it takes quite a long time, and it's no more difficult than if I just asked you for one of the terms. So I wouldn't worry too much about that. And a lot of the time you have to use your calculator anyway.